we have covered like some of the debuggers through which you can decompile the particular Android application. Like some of them were, just name them. I go with text editor. So we have covered like you can decompile an application with JADX. You can compile the application with like Android Studio. You can decompile the application with JD-GUI. You can decompile through MobSF. You can decompile through Quark, the quick Android review kit. Right, and you can also use the bytecode viewer, and you can also use the APK tool. Right, you can use any of these decompilers to decompile your application and extract the resources, extract manifest file, and extract the Java code for your particular application. Right, and after extracting these files from your APK archive, you can then analyze them for the basic functionality for your different applications. And you can also analyze the source code for your different activities and different services, different broadcast receiver, and different content providers as well. Right. So today we will cover up our first testing application, our first practice application. We call it DIVA Beta, that again known as damn insecure vulnerable application. So your DIVA Beta consists of around like 13 different vulnerable scenarios. We call them challenges. Right? But again, your DIVA Beta simply simulate 13 different vulnerable situations for like some hard coding part, for logging issues, for some data storage part, for some input validation part, for some access controls, right? These things are the basic for your source code analysis. You can easily analyze your source code and you can easily identify these kind of common weakness, right? And to simulate all these weakness, we have these 13 activities here. And for all these 13 activities, we have 13 different buttons here to access that particular activity, right? We don't have any kind of other menu here. We have simple buttons in this particular main activity here. So the main activity, and we have here 13 buttons for here. We have simple text view here, and we also have a label view here again. All these elements were known as view, and this particular string. Welcome to DIVA. This is a particular text box, right? And that particular text box was known as the view element. These buttons were also known as the view element. This particular string was displayed in a text box that was also known as a view element, right? So is the activity consists of multiple view elements, right? Now, if I go starting with the DIVA, we all know like you have to for analyzing the Java code, you can use any of these decompilers. So for the Java code, I'll be using my Kali Linux here. You can use any machine. You can even use Movaxler as well. This was just to separate our decompiler and just to separate our testing application, because I'll be using this Movaxler for my ADB commands, right? So I'll simply use this particular Movaxler machine for my ADB here. Just go with ADB devices, and devices are not connected. Let me just connect the device first. Let's go with ADB connect, and let's change the IP address to 6 and port number to 5555, and your device was connected, right? So I'll be using this Movaxler machine for my ADB commands there, and I'll be using this particular Kali Linux for my simple decompiler, and I'll be using JADX here. You can use any decompiler again. You can use bytecode viewer, you can use simple Quark, you can use MovSF, or you can use JADX as well, right? These were the common decompilers, and they were really good. You can also use them, right? Now, after this part, first of all, let's decompile our application. So here we have our application with the name diva-beta.apk. Let's decompile this application and open this file here. So in this particular archive, diva-beta archive, we got these files here, and one of them was our charthead.asim.diva, and here we have the particular source code for all my activities and all my other services and broadcast receiver and content providers as well. And so we have the source code for all our different components here, right? So let's start with our DIVA application. On the other hand, my machine, my particular Android device is connected with my Movaxler here on the left hand side. Let's start with your DIVA Beta. Let's start with the first one as your insecure logging. You can start with the objective. Let's identify the objective. Find out what is being logged, where, how, and the vulnerable code. Right? You have to figure out what elements were logged in our system. What elements were logged in my Android device. For the log part, for the basic logging, if you want to analyze the logs for an Android device, you can simply connect your device to the ADB and then you can execute the command like ADB log cat, right? It will give you the logs for your particular Android device. Like these logs were generated from your boot up to boot out. Like when you start your device will start keeping track for all the events. For all the events you have performed, all the events occurred in your Android device. All those events will be logged, right? And all the logs were managed by your Android operating system. They were not managed by any of these applications. Logs were managed by your Android operating system itself, right? Now, other than this part, here we have to identify like what elements were logged for this particular activity. Like simply, if I go with like my credit card value, something here, then I click on checkout. Then some of the elements will be logged. It's as per this particular objective. We have to identify what elements were logged in our particular logs here, right? So you can start with the simple static analysis. You can start with simple static analysis. Let's go with a static code here. Just go with your Kali Linux and you can analyze the particular activity which contains your static code for your insecure logging part. You can identify the particular activity and here we have our log activity like log activity here. And in this particular log activity class, we have two different functions. First one was your on create, which was called while when your activity will be called, right? When your activity will be launched, this particular line of codes will be executed. Another function we have here with the name checkout. Like whenever you click on the checkout button, my particular this line of codes will be executed, right? So we have a try block here, right? In the try block, we have simple command like process cc text dot get text dot to string, simple. And in the catch block, we have these things over here. Like here, basic command line number 25, like log hyphen e, whatever the exception was there, whatever exception you got, just log that exception with this particular string. Log that exception with the particular string, and you also log that particular input you have passed through this field here. Your input will also be logged here, and you can analyze this kind of thing like what elements from your input were logged in your log cat, right? So for this part, you have to analyze your simple static Java code. And here, if you have an error, you will go to toast message like toast.make text, like an error occurred, please try again later. Like if there is any error in my program, then we got this particular toast message here, right? Okay, just to identify what are the messages, what are the inputs, what are the values which are logged in my system. Let's copy this simple string from here. Simply copy the string value from here, and then we will search for the same string in our logcat command. Just copy the string and you can paste it on your Mobaxler. I will simply apply a filter. You can apply some filter from the logcat, but the simplest method to filter out some elements from your logcat is like grep command. There's some other options as well which you can, let's simply go with adb logcat and go with hyphen hyphen help option. You can see we have so many options which you can use for different kind of filters, right? The best and the simplest one was this one, adb logcat. I will simply use my grep. This pipe was used to take the output from the command on the left hand side as the input for the command on the right hand side. The output for this command will be the input for this grep, right? I will simply grep for this particular error, right? Like I want to grab these particular values from my log. Just highlight all the lines which contain this particular string, right? Or we can do one more thing. We can just try for like package name. Like my application package name was jakhar.asim.diva, right? So you can directly apply for diva here and press enter. This will give you the line of codes. This will give you line of log cat which contain this particular word diva. or you can also search for your complete package name, java.asim.diva. This will also help you in identifying logs for your particular application, or just to analyze what elements are logged for a particular application, right? So at the end, if you go here, you can see like diva-log error while processing transaction with credit card. This was my credit card number, right? This was known as your insecure logging. If your application, if your application is logging your simple sensitive information like your username and password, say like you are trying to log in somewhere, right? While logging, then you got some error, right? And if that error, if your input like username and password were logged with that particular error in your system, right? This kind of this kind of scenarios, this kind of situation were known as your insecure logging, where your sensitive information like your username, password, your session IDs, your simple pins, your credit card numbers, your name, phone number, email address, these kind of values are stored in your logs. That was known as your insecure logging. You don't have to log these kind of things. Only exceptions should be logged in your device, right? Not these kind of sensitive information. This was your first scenario. We call it insecure logging. So you have to test your application for these kind of things as well. After this part, let's move toward our second challenge. That was your, just go back. Let's go for your hard coding issues, part one. Let's open this one, the part two for the hard coding is at number 12 here. Hard coding issues part two. First, we will try with the part one, then we go towards our part two here, right? So let's open this hard coding issues part one. Again, my machine got some logs like activity manager, start this particular activity, java.asim.diva slash dot hardcode activity. Right, all the action will be stored in your logs here. Now, if I go back here, we have a basic objective, find out what is hard coded and where. Hint, developers sometimes will hard code sensitive information for ease, right? Let's figure out what was hard coded in our code here. For that part, we have to analyze our Java code. Let's analyze the Java code here. And let's figure out the particular activity which contain your hard coding word. And here we have your activity with the name hard coded activity here. So we have the same class name with the name hard code activity, and it was extended by your particular class again, app activity again. And inside this particular class, we have we have two different methods or functions we can say. First one was your on create and with some line of codes which will be executed on the create part. Second function was your access. Second function we have with the name access here, right? And in this particular access function, we have simple if else condition, right? And in the if condition, we have say like edit text, find view element, find view by ID, r.id hck. Hck is the name for your input field here. HCK is the name for this particular input field here. So the element ID we call it. We call it element ID. If you go back to your mobile slug and just search here for Android Studio, just to show you the element IDs. All right. If I came here to the activity underscore main, I'm going to the main activity here. Let's close this one and just wait for the UI. Okay. In the UI part, we have different elements here. Like we have simple text box. Again, we have some image box out there, right? And on the left hand side, if you see clearly here, if you can see, like we have basic codes here. And in this part, we have a basic ID, Android ID. This particular element was identified by this particular ID here. Right? If you want to perform any operation, if you want to use this particular image view, you have to use this one with this particular ID, image view. Right? You can, if you want, you can change this one. You can change this from this particular code here, or if you want, you can also change this from this particular attribute palette here. Right? You can simply modify the ID from here. But again, In my particular application, this particular image box will be identified with this ID, right? So all the view elements have a unique ID. All the view elements have their own unique ID, right? And for this particular input field, our ID was HC key, and you can see this thing here. This was my element ID, HC key, right? And we have again basic text like collect string, like get text from your simple user, and then convert it to string, and then compare for the equality with this string. If your input is equal to this particular vendor's secret key, only then you will get the message like access granted, see you on the other side. Otherwise, you will see this particular toast message, access denied, see you in the hell, right? So if your input is equals to this one, vendor's secret key, these kind of things which are hard coded in your code, those are the main weakness here. Your input, your simple comparison values, simple your variable values should not be hard coded, right? If you want to store these values somewhere, you can store them in a secure place. You can store them in a secure place, right? But they should not be placed directly here, right? These kind of hard coding issues are very critical for a particular application, right? So if I simply enter the same string in my application here, let's go with, first of all, let's try with ABCD. And then if I click on access, we got the same message, access denied, see you in hell. But if I enter the same message like vendor secret key, and then click on access button, we got the message again, access denied, vendor secret key. If we forgot the part, misspellings, and we got the message access granted, see you on the other side, right? These kind of values which are placed in your code, and if they were compared, if they were used for some kind of comparison to grant some access to your user, right? And this kind of strings were known as your hard coded values. If they were used for some kind of permission, for some kind of grant, for some kind of comparisons, if they were used, right? These things were known as your hard coded values. Not only these kind of things, your API keys, your as well, like your encryption keys, the simple encryption algorithms can also be the part there. But these kind of issues, like simple encryption keys, simple this kind of strings, simple API keys, right? Your simple access codes, your simple tokens, your simple session IDs, and all other different things. Like username and passwords are also there sometimes, right? These kind of things were known as your hard coded values, and they should not be placed in your code, right? Other than this, if I go with the next scenario for the hard coding part, let's go back and let's go with the second hard coding challenge at number 12 here. Hard coding issues part 2. Let's open this one. Again, we have the same objective and we have the same hint here. For the hint part, hint was exactly same and the objective was exactly same. So again, if I try the same, if I try the same tricks over this particular hard coding issue part 2, let's figure out the activity. We got the activity here just above this last one. Activity 2, sorry, hard code 2 activity. Let's open this one. And here we have the same class name, this one. And here we have a private, here we have a private word here, DJNI. It was derived from this particular DIVA JNI class, right? And your class can be seen here. We have a class with the name DIVA JNI, right? And on the in this particular hardcode 2 activity, we have a particular object for this class DJNI, right? On the after this code, we have basic two different methods here. First one was your on create, and second one was your access. This particular line of codes will be called while simple when the activity will be called. When the activity will be started, your this line of codes will be processed, right? After this part, like we have simple new object here, simple part, simple definition for your object was here. After this part, we have again the access function here to grant the access or to deny for the actions, right? We have simple if we have simple comparison here. like this .djni dot access the basic. I'm calling a simple object. I'm calling a simple function from this object djni dot access, right? And comparing it with not equals to 0. But I'm calling some function from this djni class here. So here in this particular part, we have to analyze the code for this djni class. So let's go back with our djni diva jni class. And in this particular class, we have basic line of codes which was used with the simple static part was there, like we have simple int access, we have simple int part, we have simple access int function was there, right? Public native int. It means we have native code out there. For this particular part, we have native code. And when you write the native code, for native part, let's say like for your simple mobile application, you can use, we generally use Java or Kotlin, right? But if you want to use the C language for your basic functionality, if you want to use some C language, you can use C language as well, right? But in that case, your C language will be processed, will be compiled, and it will be stored in form of your libraries. Your code for the C language will be compiled and it will be stored in your libraries here, not in your source code here, right? So on this particular part, we have a native function with the name int here, which will return the int value, right? And we were using a string str attribute out there, right? If we go a little bit down again, we have one more function there, and a basic string function with the name system.load library so name, right? We can't analyze this much. We can't analyze this particular function anymore. Let's go with our simple library because we have a native library here with the name diva jni, right? So name was the object simple final simple string variable name was so, and this variable contained the word diva jni. But we have a library here for our native codes out there. So for the library part, you can extract the library. You can extract the library from the device itself. You cannot extract the library from your application. No, you cannot perform this thing, right? So for that part, for your libraries part, you have to go with your Android device, right? And if you remember the last session, I have told you that all of your application data was stored in this particular directory. If I go with simple adv shell, go with this one. And again, let's go with adv shell. Now, in this shell, all the user data, all the application data was stored in this particular data folder, right? And inside this data folder, we have again multiple folder. Out of all these folder, we have two important folder. First one was your application app folder, and second one was your data folder. Again, all your application files like simple apk files, simple libraries will be stored in this app folder, right? And all the application data will be stored in this data folder. Application data will be stored in data folder. Application files will be stored in this app folder. Simple, right? So here we want to extract the library file. For this particular application, we want to extract the library file, right? So library will be available in this particular folder app. Let's go with this particular folder cd app, and in this particular app folder, we have different folder for our different application with their package names, right? If I go here, one of my package name was jakhar.asim.diva-1. Let's go with this particular folder as jakhar asim diva-1, and let's open this one. In this particular folder, if I go with ls-l again, you can see we have again different two folders. First one is my lib for my libraries. Second one is my OAT, and we have one more file with the name base.apk, right? So we were focused on libraries. So just go with lib, and inside this lib, if I go with ls-l here, we got a file we got a folder with the name x86. So let's go back to this x86 folder, And inside this folder, we have a file with the name libdivajni.so. We got the library here. Now, the point is, just because this library is compiled, this is the compiled library, right? So you cannot analyze the source code, or you cannot extract the source code easily, right? The simplest method is, if you have access to the source code, then you can analyze the source code. Otherwise, if you try to analyze the compiled library, if I simply go with cat command for this particular lib file and press enter, you will got this kind of Mojibaki character. This kind of boxes were known as your Mojibaki character, which means they were not displayed on your particular machine. They cannot be displayed here, right? Because of some language barriers, you can say, right? So, what can you do in that case? What can you do? We will simply extract the valid string. Like we can see some of the text there, like simple. This was a text. This was again a text. This was again a text. This was again a text, right? So what we will do, we'll simply extract all the simple string values from this particular library file. We will simply discard these Mojibaki characters, and we will only filter out the string values like these one. We'll only filter out the readable strings from this particular library file, right? So for that part, you can simply use the string command, and then you can specify the library name, right? And just press enter. Just go with the strings and then press enter, right? This will give you a list of all the strings which are available in that particular file, right? This particular strings command is used to extract the string values. Like if you have three or more than three characters, if you have three or more than three characters with each, let's say, like if I go with this one here, like we have a group of three characters like G and U, right? If you have these kind of three characters with each other, and if they were displayed here without any kind of Mojibaki characters, like we have GCC, right? This is a valid string value for your string command because we have three characters here and they were displayed properly, right? So your string value will simply give you the list of these kind of characters, right? And we got a list of all these kind of characters, like GCC was also there, you can see, right? We got the proper string values from your library file. So in that case, what you can do, you can simply try all these strings one by one for your hard coding file. Just by analyzing your Java code, if you feel like this values will be somewhere hard coded in your libraries, or the value for this secret will be somewhere available in your library, and you don't have access to the source code for your library, then you can simply use this kind of strings command to filter out or to extract the valid strings from your file, and then you can try all these strings one by one. And if any of that string was used for the comparison with the if command simple, then you can track the authentication or the authorization as well, right? So what you can do, you can simply try all these kind of words one by one. You have to try all these words one by one, right? But again, it will take a lot of time again. It will take so much time. So for the DIVA beta application, what you can do, like DIVA beta application, we have the source code, and the source code was available here. Just go with the link like github.com/pr2, and in the pr2, we have the particular application name diva-android. Just open this one, and you can go with this particular app folder because all the files will be stored in this particular app folder, right? Just open this one. Inside this, you have the src folder for your source code. Just go with the main folder here, and let's open our JNI. Let's open our JNI. If you want the Java code, you can go with this one. But if you want the JNI, the native code, you can go with this JNI. If you want the resources, you can go with the resources, and manifest file was also here. Other than this, right now I'm going with the JNI, the Java native interface. Just open this one, and here in this JNI folder we have multiple other files, right? And you can also go with this file specifically, like diva jni.c. So this was a C language. You can easily analyze the C language here. Let's open this file, and this will give you the source code for your particular application here, right? If you start analyzing this code, you can see Like we have the basic import lines for your Diva beta application. Sorry, for your simple string, for a simple C language. We are importing some libraries, right? And then we have a basic definition for your constants. Like we have a constant with the name vendor key, and the value for that constant was OLSDFGAD semicolon LH, right? So you can try this simple vendor secret key which was hard coded in your libraries. Not all the values were hard coded in your Java code. Some of the values can also be hard coded in your libraries, but you have to analyze the proper functions to find out that your values were hard coded or not. And if they were hard coded, they were hard coded in the Java code, but they were hard coded in some libraries. You have to figure out these things from your analysis, from your simple Java code analysis part here. You can analyze your all the activities, all the functions to identify these things that your code, that your values were hard coded, or they were just validated over the server, right? And if they were hard coded, where they are hard coded, right? You have to figure out these things. Other than this, if I try this simple string, let's try this one. Let's enter this one as if I try ABCD here first. Let's go with access. We got the same message, access denied, see you in hell. But if I try the same string like OLSDFGAD semicolon L and H, right? And then click on access, we got the message access granted, see you on the other side. We got the message here, right? So this was your second challenge for your hard coding issues. Your values, your string part can be hard coded in your Java code, and it can be hard coded in your libraries as well. You have to test all the things. Now, other than this simple hard coding part, now let's move toward our third challenge. That was your insecure data storage, right? Your data can be stored on multiple locations. Like it can be stored on simple temporary files, it can be stored on databases, it can be stored on simple like shared preferences folder, it can be stored on simple external storage as well, right? And to identify where your simple data, any kind of data, where your data was stored, to figure out these things, you have to analyze the Java code, right? To identify where your data was stored, you have to figure out, you have to analyze the Java code. So let's give it a start. Let's go with our third challenge for insecure data storage. Let's open this one. And here we have the basic objective, like find out where, how the credentials are being stored and the vulnerable code. Hint, insecure data storage is a result of storing confidential information securely on the system. It means poor encrypted, plain text, access control issues, and etc. thing was also there, right? So first of all, let's add some values here. I'm going with my name as like Siddharth, and then go with the password as my surname like Sangwan, right? And let's click on the save button. We got a toast message, third party credentials are saved, but we don't know where these values are saved, right? For that part, we can simply analyze the Java code. So let's go with our Java code again and let's figure out where is our activity for your data storage we have here. So your particular activity for your data storage, right? You can analyze the source code from here. So again, for this particular class, insecure data storage activity, we again have two different methods. First one was your on create part, and second one was your saved credential function, saved credential method, you can say, right? When you simply click on this saved button, when you simply click on the save button, it will perform the action. It will perform simple actions like these line of codes will be performed, right? So according to this line of code, we got a simple object for this particular class, and to use this particular method editor here for your shared preferences class, right? So we got an object with the name sp edit, shared preferences edit, maybe for the short form. Sp edit was here. Then we got some simple preference manager dot get default shared preferences this dot edit. It means this particular object will be used to edit or to modify the values in your shared preferences, right? Again, spedit dot put string your username and collect your username from your this particular element ids 1usr, right? You will simply collect the input from this particular username So you will collect the input from the user from this particular IDS1 USR element, and you will store this with the user word here, and you will put them in a file in your shared preferences folder, right? And we'll commit those changes with this particular commit line here. And after committing all those changes, we will simply display a toast message like third-party credentials saved successfully, right? Then, so it means according to this line of code, it means your data or your simple credentials were stored in your shared preferences, right? So for that part, if I simply open my shared preferences folder, you can access that part. As I told you, all your application data was stored in this directory: cd, data, and data. All your application data will be stored in this particular directory, right? Application files will be stored here in data and app folder, but application data will be stored in this data directory again, right? So if I go here and press enter on this in this particular directory, we again have different other files and folders. You can say one of them was your Jakhar Asim Diva. Let's open this one, like Jakhar Asim Diva, and in this Jakhar Asim Diva, we have again different folders, and one of them was your shared preferences. We have a folder with the name shared preferences here. You can see, right? So let's open this folder with the name shared preferences and press enter. Right inside this shared preferences folder, if I go with ls-l here, we have a file with the name jakhar.asim.diva_preferences.xml. Right? Let's see the content because this one is a simple file. This one is a simple file. Right? It means we can analyze the proper code for this particular file. Let's go with simple cat command and let's print the content for this Jakhar Asim Diva preferences.xml. And we got your content here. Like this was my name, this was my username as Siddharth, and the password was simple Sangwan. Right? Again, my credentials were stored in this particular file at shared preferences. The main weakness is not the storage part. The main weakness is not the place where your data is stored. The main weakness is your data was stored in form of plain text. You can store your data anywhere you want. You can store your data in your any folder, in any location, doesn't matter. The main weakness is your data was stored in form of plain text, right? And any kind of data, any kind of sensitive data should not be stored in form of plain text. You have to follow some kind of encryption over the data. After encrypting the data, you can place it anywhere. You can even just gift it to the attacker. Even then your data was secure. If you even gift the data to the user, to the attacker, even then your data was secure. But for that, you have to encrypt your data, right? If you encrypt it, your data was almost secure because it's very, very, very hard for anyone to crack the encryption, right? So the important weakness was here is your plain text data storage. You can store it anywhere, doesn't matter where you are storing. But if it's stored in form of plain text, this was the main weakness, right? So for this particular scenario, my data was stored in form of my shared preferences, and you can access the data stored in shared preferences from this directory, like data, data, then your package name, and then just go with your shared preferences folder, and you will got your files. Simple. Your data was stored in shared preferences. You can easily access the data. Now, if I go with next challenge, let's go with next one here. Just go back. And now let's move toward our next challenge for your insecure data storage part 2. Let's open this one. Again, we have the same objectives here. We have the same hint out there. So let's analyze our Java code because we don't have any special hint or special objective here. We can only analyze our Java code for the proper analysis of this activity, right? Like how is this particular scenario different than the last one. To figure out this thing, we have to analyze our Java code. Let's go back with our next activity in secure data storage 2 activity. Let's open this one. All right. To this particular activity, we can say like we have a class with the name insecure data storage 2 activity, right? And in this particular activity, So in this particular class, we have an object with the name MDB from your SQLite database class, right? We have an object with the name MDB, and with that MDB, after MDB, we have basic two different methods. First one was your on create, second one was your save credentials, right? If I go with on create part, we have simple some line of codes is here. We have the basic line of codes here. Like if I go with simple try block first, then we have basically like this dot mdb equals to open created open create database with the name IDS2 0 and null, right? We have the basic part here like open or create database IDS2 0 or null. If you have a database, then you can open this one, open this database IDS2. If you don't have the database, then just create the database with the name IDS2, right? After this next line, we have this one like m executable, execute command, create table if not exist. If not exist, my user. This is my table name here. This was my database name as IDS2, and this was my table name as my user. And in this particular table, we have two different columns here. First one is my user column which store variable characters. Second one is your password column which again stores your variable characters here, right? In the catch block, we simply log some values like error occurred while creating database, and that message will be stored in your logs for your particular exception, right? Then after this part, we got the basic function of our simple save credentials, right? So in this particular function, again, we have two set. Again, we have the simple try and catch block here. And in the try block, we again have the same. Again, we have just simply perform some operation like execute SQL command like this one. Insert into my user, because this one is again your table name. Then first value you are inserting is like collect your input from your user and convert this one to your string. After this part, again collect your input from your this particular element IDS to PWD and again store it as in your next column, right? After this part, you have the basic like close your database and then you have a basic our exception part and then toast the message third party credentials have saved, right? Just by analyzing this thing, you can figure out that's your Java, that's your input, your username and password from this particular activities here like username and password. Your username and password will be stored in form of your database, right? So let's give it some username and password. I'm going with simple row as user and let's go with password as password, right? And let's click on the save button to save our credential. And it says third party credentials saved successfully. Now, if I go back to my ADB shell, you can also access the databases directly. For the ADB shell, you can just go with this simple mob explorer again. And let's go with the same folder again. Just because these credentials were saved by your application, they were saved by your application. It means this was your application data, and your application data will be stored in this directory /data/data slash your package name, right? If I go back one more time, and if I go with ls-l to list out all the folders in this particular package, we have a folder with the name databases. We have a folder with the name databases, right? This one is just the link. These two and other, these two are again the folders were there. But first one is your cache folder, second one is your code underscore cache folder, third one is your database folder, and fourth one is again a link for your libraries in this particular location. Data, app, Jacker, Asim, Diva, -1, lib, x86, right? A simple link for your libraries. Again, after this part, we have a folder with the name shared preferences. But right now we are focused on our database folder. Let's go with this. Let's go with this particular database folder. Just go with cd databases, and if I go with ls-l in this particular folder, we can see like we have four different databases here, right? First one is your diva notes.db. Second one is your diva notes.db journal, and third one is your IDS2. Then we have IDS2 journal, right? So here we have four different databases which you can access. So to analyze the content for your database, all you have to do is just download these database files. And for downloading, you can just go with simple exit, and then you can use the command adb full, and then just pass your path from where you copy, where you want to download the files. So I'm simply downloading my files from this particular folder, slash data slash package name as Jaka Racine Diva, then download the database folder. In this particular folder, documents, right? And let's press enter here. Now, all your files, all your particular 4 databases will be downloaded in this particular document folder here. So let's go with this database folder, the cd like documents, and inside document we have our database folder here. And in database folder, you can see we have 4 different database here, right? And to analyze the content, you can simply use this kind of database browser like DB. You simply search here on mobile slug. We have our DB browser for SQLite. You can simply open this one, and you can open your database from these buttons, and then you can go with your proper path. Just go with your documents and go with your particular database folder, and we have a single database here like diva notes.db, but we have a different database to target. In that case, just close this one and open your file explorer, browse for the folder. Like I'm going with documents here, and in document we have the folder name database, and in database we have folder name, we have database name like IDS2. Just drag and drop this database file on your DB browser, and this will show you the content. So we have 2 different tables in this particular database. First one is your Android underscore manifest, and we have one more table with the name my users, right? So if you want to analyze the content for this my user table, just go with this browse data tab here. Just open this one, and here you can switch between your multiple tables. From this drop down arrow, you can switch between your multiple tables here. So I'm right now I'm going with this particular my user, and here we have our path. Like we have 2 entries here. First one is your username, and we have 2 entries as Craw and Craw, and we have password as security and password. These were my last entries, and these were my recent entries, right? So you can also analyze the database content through this kind of thing. Again, the weakness is your plain text data storage, not the place where you are storing. The weakness is your simple plain text data storage.